The curve has parametric equations x equals tan squared t, y equals sine t, where t is between 0 and pi over 2. Part A. Find an expression for dy by dx in terms of t. So, we're going to use the formula dy by dx is equal to dy by dt divided by dx by dt. So first we're going to differentiate our x and y functions with respect to t. The x function, x equals tan squared t. Just to help me demonstrate the chain rule here, I'm going to write this as tan t all squared like that. This is the same thing as this. So differentiating this with the chain rule, I'm going to differentiate the outside function first. So differentiate the squared part. So I'll get 2 times tan t with the power now being a 1. I now need to multiply this by the derivative of the inside function. The derivative of tan is sec squared. So that is my expression for dx by dt. Now differentiating the y function, the y equals sine t, differentiating sine, I get cos. So substituting those into the formulae, I'll get cos t over 2 tan t sec squared t. And I could leave my answer like that. It does say you do not need to simplify your answer, so leaving it like that is perfectly fine. However, I can see in part B, it says, find an equation of the tangent to the curve at the point where t equals pi over 4. And substituting pi over 4 into this, the way it's written at the moment, is a bit awkward because I can't really substitute sec squared. So I am going to simplify this a little bit. The sec squared, I know that sec squared is the same thing as 1 over cos squared. So I could rewrite this as cos t over 2 tan t times 1 over cos squared t. And then simplifying this fraction by multiplying the top and the bottom by cos squared t. I'll get cos cubed t on the numerator, and on the denominator I've just got 2 tan t. That just makes it a little bit easier for me to now substitute the pi over 4 then. So when t equals pi over 4, dy by dx is equal to cos pi over 4 cubed divided by 2 times tan pi over 4. And substituting that in, I find that I get root 2 over 8. So that is the gradient of the tangent. So I can now say y equals root 2 over 8x plus c. I just need to find out a coordinate now. The x and the y coordinate when t is pi over 4. So let's take the pi over 4 and substitute that back into the original equations. So when t equals pi over 4, x is equal to tan pi over 4 squared, which is just 1. And y is equal to sine pi over 4, which is root 2 over 2. So substituting those into our y equals mx plus c now. And rearranging this to work out c. I find that c is going to equal 3 root 2 over 8 So my equation of the tangent then, y equals mx plus c. And that is how I'm going to leave my answer. This is in the form y equals ax plus b, where a and b are constants. So that's my answer for part B. Moving now to part C of this question. Find a Cartesian equation of the curve in the form y squared equals f of x. So I need to eliminate the t's. I need some trigonometric identities that are going to allow me to link these two formulae together to get y squared in terms of x. So I've got a tan t there. In fact, I've got a tan squared t. So I can rewrite that as being sine squared t over cos squared t. So I'm just rewriting the tan squared as sine squared over cos squared. Now that's useful because I know that y is sine t. So sine squared t, that's just going to be y squared. So that's nice and simple. Not quite sure what cos squared is directly, but I do know that cos squared is the same thing as 1 minus sine squared. So if I replace the cos squared with 1 minus sine squared, then that's going to be really useful because now I know that this is y squared and I know that this is y squared. So I can now say that x is equal to y squared over 1 minus y squared. And I'm just now going to make y squared the subject. So multiply both sides by the 1 minus y squared. Expand those brackets. Move the y's so they're on one side together. Factorise. And then divide both sides by 1 plus x. And that is my answer for part C.